The overall goal of the following experiment is to optimize virus recovery from water using a small-scale technique originally designed to optimize virus concentrations. A glass cellulose filter was found to be the best electropositive filter to concentrate adenovirus from water. For the secondary elution, a C-light secondary concentration technique proved to be best for eluting adenovirus from the filter surfaces. The resultant technique recovers the most adenovirus from tap water, based on having the highest percent recoveries observed between all tested filter and elution combinations.
The main advantage of this technique over existing methods, like large-scale volume concentration, is that it utilizes smaller sample volumes, enabling a multitude of concentration variables to be evaluated quickly and easily.
When preparing for this protocol, have all the required solutions at the ready, including the 0.22 micron filtered viral solution at 10 to 100,000 mpn per milliliter. Begin by measuring out a liter of sterile tap water. Transfer it to a 2-liter beaker with a magnetic stir bar. While stirring the water, add 0.7 grams of sodium thiosulfate and allow it to dissolve completely. Then, adjust the pH to between 7 and 7.5 by adding 1 molar acid and base stock solutions dropwise. Next, spike the water with virus. Add a full milliliter of the prepared virus solution. Cover the flask with a sterile wrap and let the virus mix into the water for 10 minutes. Meanwhile, prepare the millipore filter. First, unwrap it from